podcast. This is Mr. White.
And Mr. Sadler.
And today we're going to talk about problem-solving strategies. And,
really putting it all together, right?
yeah, putting it all together. Much to their frustration, Mr. Sadler, physics involves math.
Right.
But physics is not math. We are just attacking these roller coaster questions in different ways.
Right.
So there are two basic approaches that we've been really focused on actually since August.
Right.
One of them is to focus on scalars. And the other is to focus on vectors. So a scalar, refresh my memory.
It doesn't have a direction.
Yeah, so it's a number without a direction.
So, I mean, I don't want to give away the secret, but it's really energy, right?
Yeah.
Energy doesn't have a direction. It's just
So our
scalar.
our scalar problem-solving strategy is to analyze with energy. So I like to think of this as accounting. Why would I say that?
Because the energy at the top of the hill, the gravitational potential at the bottom of the hill turns into 100% kinetic. So it's just finding the energy where, right? I mean,
Yeah,
it's
that's
just looking
basic.
for it.
That's basically it. Is whatever I have in the beginning is what I have to have in the end. It's like balancing a checkbook. You start with X dollars. You're going to spend X dollars, and well, if your checkbook's like mine, there's always zero left when I'm done, right?
Right.
And then there's this vector solution. And vectors are numbers with direction. And when have we focused on vectors?
When we talk about forces, right?
Yeah, force. And unfortunately, accounting is somewhat easy. It's just simple. Okay, we have all of the energy here, and we have all of the energy over there, and we have all of the energy at every point in between. But this direction concept means that things can be positive, they can be negative, we can have angles involved. This is a very messy solution. And this is not accounting. This is trig. This is horrible sometimes. But the benefit of vectors is that they're more descriptive. And we can actually get more information out of a vector than we can out of an energy solution. So scalars versus vectors, or
Energy versus forces.
yeah. Now the good news is we've been doing this all semester. We've been talking about, well, this is why we talk about car crashes, and this is why we talk about roller coasters, and why we talk about jumping, and sometimes we use all these different considerations. So the thing that ties it all together, of course, is work. Because work can be the change in energy, and the other side of this, work is
Force
times
the distance.
times the distance. And so we have our scalar meets the vector. And so this is our go-between. This is the idea that we use to bring the whole picture together. So the change in energy, specifically, we've been focusing on the change in kinetic energy, but we can do work to change gravitational energy. We can do work to
Change spring potential.
spring energy, pull or compress that spring. Of course, we can vary how much work we do by applying a bigger force or a smaller force. We can apply the force over different distances.
And that's what car safety is.
Right. Whether we were going to we were talking about airbags and work. So this all feeds in, and it's important to know that these ideas don't stand alone. Okay. So when to use energy, okay, and when to use force. And so the really exciting roller coasters, Mr. Sadler, what do they have a lot of?
Gravitational potential, a lot of speed,
Okay.
a lot of height.
So you just mentioned three things that are scalar quantities, right? So if we have this roller coaster with loop-the-loops and horizontal loops, and it goes up and down in every which possible direction, if I had to pick what was happening at any one point in time in terms of direction, I would pull my hair out
Right.
trying to figure this out. So just like the roller coaster I have set up in my classroom, if I were you, when I start seeing, oh well, it starts up here with a lot of height, and I want to know about the speed down here, does all of this in between matter?
Oh, it matters, but if I'm looking for a total, if I'm converting from gravitational to kinetic, it doesn't matter.
No, this doesn't matter at all because all we care about is the beginning and the end. So we use energy or we use scalar when we have a beginning and an end.
The funny thing is, in class, whenever I talk about this, I always say the first thing you want to do is see if you can find a place where it's max or where it's zero.
Yeah.
And so it sounds like to me, if you're doing energy, you want to find out, can I find out where it's max or zero? And then it makes the starting point at least reasonable.
What I like to do, I first of all, I like the energy solution. I prefer energy over working with forces any day of the week. But there is a time when you have to use forces, and ironically, you need to use forces when you need to know about time, which is strange, because time, of course, is a scalar. Yeah. So you use forces when you need to know about time, because this goes back to some Chapter 1 discussions. Stuff changes over time.
Right.
So velocity is a change in distance or displacement over time. And acceleration
Right.
is that change in velocity over time. Now, we saw that it's not impossible to find acceleration without time, but it certainly makes it easier. And if we know this acceleration now, okay, because of Newton's second law, F equals ma. So we take that acceleration that we can find, and then that makes forces an easier way to go about this.
Sort of shows you how it's related to F equals ma. Forces, certainly you're going to use acceleration.
Right. And if you think back to any of your energy equations, kinetic energy, gravitational potential, spring potential energy, there's no mention of acceleration. There's no mention of time.
Right.
There's no mention of direction. Remember, acceleration, of course, is a vector, can be positive or negative. So if you've got to deal with acceleration, you've got to do for the force solution. And if you don't need to know about acceleration and things like time, well, then you focus on energy, and height and speed are the way to go. Direction doesn't count.
So we've given some hints.
I hope so.
If you can get a zero or you can get a max, you might want to be using energy. And if you're looking at time or acceleration or velocity, you might want to be using force.
Right. And so the key, of course, is I believe in the investigation that they're going to do at home. They're making these concept maps, and at some point we'll post the textbooks version of this, and that's really a sight to behold. You got to get past the enormity of it at first, but when you start to think about, wow, I've learned all of this semester, you guys have done a really nice job at doing that.
Right.
So I believe that wraps things up, differentiating between energy and force, scalar and vector. So signing off, this is Mr. White.
And Mr. Sadler.